Hi everyone, so welcome to our study jam. Our first ever study jam from GDG is going to be about Google BigQuery. So what is BigQuery? BigQuery is a serverless data warehouse widely used in the industry for big data analytics and business intelligence. So you can see companies like Spotify, X, HSBC, and the New York Times uses it. And this is our presenter for the night, Ling Chen and Ahmed. They'll be guiding you guys through the BigQueries.
Good morning, we're doing good. So as we go on to the first slide, what is BigQuery? And we're going to discuss what is BigQuery, its features, its industry use cases, and we're also going to have some hands-on with SQL and its syntax in BigQuery as well. Um, so what is BigQuery? BigQuery is basically a serverless, fully managed data warehouse by Google Cloud. So for example, when you run SQL queries on your local desktop, right? Instead, BigQuery is managed. BigQuery is basically hosted on cloud that is developed by Google. It allows fast SQL queries on large data sets. That is, for example, if you're hosting a data set locally on your laptop, it might take a long time to run a simple query. Whereas in BigQuery, Google provides free resources such as CPU, power, and stuff, which helps boost the workflow a lot. It's obviously scalable. It's optimized for big data analytics. There are new features coming as well, such as data canvas and stuff. Further on, so for our specific application, we're going to be using BigQuery Sandbox. This is a free version of BigQuery. There is no need for billing. Whereas if you use the main BigQuery, you need to put your credit card details as well as purchase a plan. The BigQuery Sandbox is obviously limited. There is maximum 10 GB of storage and 1 TB of query processing per month. So as we go on, like the workflow starts like first you need to like run SQL queries. You obviously need data, right? So you need to load data into BigQuery. There are multiple options to load data. You can just upload a CSV file from your laptop or an Excel file from your laptop directly into the cloud server using BigQuery's interface, or you could use Google Cloud Storage. You could also connect it to your Google Drive as well. There are some other external sources as well which are available in BigQuery Sandbox to connect and upload. Further on, if you go on to the future, we're going to be going into more detail after these slides when we're going to be practically using BigQuery with SQL queries and some data sets that we prepared for you. But for now, you can perform SQL queries for interacting with databases by retrieving, modifying, analyzing, and managing data, obviously. Further on, you can store a loaded data set, so you can use it later on as well, and you can save tables using one query. Also, if you run a query, right, you can easily save it into BigQuery and use it next time when you open BigQuery Sandbox. You could save the results as well into a CSV file, or you could share it into your Google Drive. Further on, if you go about the basic SQL syntaxes, BigQuery can also use Python, but it's mainly made for making SQL queries on data sets. What is SQL? So SQL, it's the short form for Structured Query Language. It is used to retrieve and manipulate data from databases. You can obviously use statements like select, from, where, order by, limit, and join clauses. The select statement is usually used in the very start of any SQL query. It is used to select any columns from a dataset. The from indicates which table to use it from, which is basically, for example, in a dataset, there are multiple tables of data. Right? So you use the from statement to identify which table you're going to be using from the dataset. The inner join is basically if you're combining two data sets. So you can't directly combine them. You need to choose a common column to combine them on. So you use the inner join column, the inner join statement, basically which indicates the other data set to combine. And then you use the further on the on statement to indicate which column to which common column to combine on. The where condition is basically where you indicate, for example, if you want data, for example, age, if you want data where age is greater than 50, or if you want data where somebody's blood group is A positive. So that's how you define conditions in the where statement. And then you can also order your resulting dataset in descending or ascending order, and you can choose a specific column to order on. For example, in this syntax, right, we're using the column one to order in descending order. And the limit 10, when you create a new query in BigQuery Sandbox, it usually writes the limit by default. The limit basically indicates the output to a specific row size. For example, in this case, it says limit 10, which means it's going to be restricted to 10 rows. If we look at this example query, what it does is it selects the disease. It selects the average of patient age column, the feature. You can also call it the feature or the column. Both of these terms are used interchangeably. And then the patient age, the average of the patient age feature is given an alias called average age, avg underscore age. And this is all imported from the dataset name dataset and the table called medical records. And this is group by disease. The group by statement is basically used sometimes to perform aggregations of data as well as carry out other analytic operations. Further on, if you go to the industry user BigQuery, since it's a new technology, it's already setting into the industry very recently, but it's setting it at a very fast pace. If you look at the retail and e-commerce industries, an example query could be we need to find our top selling products in the last 30 days. So the data for the 30 days could be very large. It could be very large set, and manually filtering out top selling products is not easy. So what you can do is you could use BigQuery to define a criteria for top selling products, and you could easily filter that out. For the finance and banking, you could detect high value transactions. You could set a threshold for the transaction price to be greater than a certain amount, and then you could filter the data sets for that. And similarly, for healthcare and life sciences, you could get the average patient age by disease type. For example, you could set a condition, for example, a disease to be like flu or something, and then you could average out the patient age for each disease. Further on, so now I'm going to be showing you the practical use of BigQuery. Just give me a minute. Okay, so as you see, for this practical application, we are using the fraud detection method. We use it from we got it from Kaggle. There are a wide variety of data sets available there that you could obviously download and use. What Okay, so do any of you know what Kaggle is? What is Kaggle used for? Any any ideas? Any hints? Any responses?
I remember correctly, it's used for to like deploy models, for deploy models
Uh,
specifically.
partially correct, but there's a lot more use of Kaggle. What else? So Kaggle can be used to get datasets that you can practice on, datasets that you can learn on, as well as Kaggle also provides creative notebooks. from which you can carry out queries on your dataset in SQL as well as Python. So the dataset we are using is this one, bank account fraud dataset suite. It's by Newer IPS It's by Newer IPS and was produced in the year 2022. Um, so there are multiple features in this dataset. First is obviously the fraud booleans. If we want to detect if a transaction is fraud or not, these are in zeros and ones. Further on, there is income as well, which determines the annual income of the applicant, which is getting which is either getting into a fraud or which is either making a transaction. There are other features as well, such as name, email, similarity, which is the ratio feature. Further on, also, if we talk about the fraud union, this is the categorical feature, since there are only zeros and ones, which indicate, for example, one if fraud and zero if it's a legit transaction. Further on, there are demographic features as well, such as customer age. This indicates for each transaction what is the customer's age. Certainly, whenever we use models like logistic regression model or random forest model, they notice trends, they notice changes in the data. So features like these allow them to basically filter out transactions. In this case, to filter out transactions by noticing the trends in data. There are for this test there were around 6 variants, including the base variant. However, since there are many datasets supported on Kaggle, some are even artificial datasets, some are even natural datasets. So we picked out the base CSV, which is the most raw version of this dataset in this case. Now we're going to walk through the BigQuery sandboxing interface. The thing you see on your left is the Explorer, right? And this is the main project name. In this case, tech team dash hyphen 44821 is the project name. These are the queries, the repositories, and then if you go further down, these are the data canvases. As I all told you, there are different features. There are different features in BigQuery which helps you explore data, which helps you as in like detect trends in data and learn more about it. You can also create pipelines. Pipelines are basically, does anybody of you know what pipelines are? Are there any CS students who know what pipelines are? No? Okay. So pipelines are basically automated data cleaning or data exploration code. As in, you can, for example, if you create a pipeline, filter data. For example, there is a common thing whenever you load a data set, you need to drop the empty columns or empty cells, right? So you can create a pipeline whenever normal a raw data set is loaded, it can directly drop all the rows with empty cells or drop all the columns with empty cells. Further on, if we talk about this, this is our table. This is the data set, which is the fraud detection, and there are multiple tables in this. The first one is called normalized numerics, and then and then you also resample the data a bit. We have final data frame, fraud, housing, etc., etc. Now we come to the queries. So these are all the queries we are combining into one. If we, there are basically as I showed you all in the slides, right? There are basically 4 steps of creating a ML model. Majorly 4 steps of creating an ML model. They are data manipulation, data normalization, and then you train the model on the data, and then you test it using your test data. So for the first query, what it does is it includes the fraud source feature because it's a categorical feature, right? Then the values in the fraud source column, the feature are internet and teleapp. So what it does is it replaces internet with zero and it replaces teleapp with one. And then it creates a new column called source encoded, and it deletes the old column which was source from the previous editor and stores it into this new dataset called fraud detection. Called fraud source, which can be found on your website. As you can see, the source has been encoded. The source has been encoded. Zero was for internet, and one was for Telegram. Further on, if you go on to the another encoding query, what it does is it takes a target encoding feature. It selects the device OS and it averages out the fraud Boolean columns. And it basically creates a new column called device OS encoded. And it picks these features from the fraud source encoded table we just created above, and then it stores it into the fraud device OS encoded. So what we're doing is piling up each encoding feature. First, we store the fraud source encoded in fraud source encoded table, and then we store the fraud source encoded as well as the fraud device encoded in the new table. Further on, um, if we go to another query, we encode the housing status feature. If you can see the housing status feature, you can see this is also a categorical feature since there are strings instead of integers, indicating what is the housing category or the housing status. This is the anonymous feature since we don't have a definition for what the values mean. We You can usually read about a dataset in its documentation in Kaggle, which is easily available. In this case, this is an anonymous feature. So what we do is we replace the housing status, the features in the housing status column. For example, BA is replaced with 1. If B is not there, we replace it with 0, and then we create. Basically, what we're doing is for the BA, right? We're creating a new column called housing status A. Since Yeah. So we're creating a new column called housing status A, and if there is BA in housing status, it is marked as 1 in housing status A. Whereas if there is not BA, it is marked as 0. And same goes for the other values in the housing status. That is BA, BB, BC, BD, BE, BE, BF, BG. And all of this is stored in the fraud device. All of this is stored in the fraud housing status encoded table. Further on, does anybody have any confusions or anybody wanna ask anything? Anybody wanna ask anything? Um okay. So let's go on to the next encoding statement. What this does is we look at the payment type column in this data set, right? So as you can see, it has different categorical values. In this case, it has A, B, B, C, etc. What we do is we check if the payment type column has the value double A. We create a new column called payment type A, and if double A is there in the original payment type column, we replace it with 1 in payment type A column, and if it is not there, we replace it with 0, making it like converting it from a categorical feature to a feature uh, that can be used for models or for the models training. Further on, we also need to normalize features, especially numerical features, with using techniques like min-max scaling or z-score normalization. And sometimes the data is not normally very defined or straightforward. Sometimes the data is skewed left or skewed right, so it needs to be normalized to the center so that get the model can get the proper trend in the data. If we talk about Z-score normalization, what it does is it selects the session length in minute and it minuses the average session length in minutes from the original column for each value. Secondly, it divides the result by the standard deviation of the session length in minutes. This is all this is all arithmetical calculations used to do Z-score normalization. And then finally, it's again replaced in the session length in minutes column, the final Z-score normalized value. Same is done for all the other columns that are credit risk score, intended Balkan amount, zip count, velocity, 6 hour, 24 hour. These are different velocities for different time periods. For example, for 6 hour, there would be another value. For 24 hours, there would be another value. Same goes for 4 weeks. We also have the value for bank branch count 8 weeks, which basically measures how many branches of the bank are there in the first weeks. Further on, if you go on to the min-max normalization, this is another normalization technique that is, for example, if you have data between a range of 1 to 100, right, and you want to scale it from 1 to 5, you can use min-max normalization to scale that data. The technique used is the original value is the minimum or the original value is subtracted from the original value, and then it's divided by the range of the original value, and then it's obviously replaced with the main value that was being used since it's min max normalized. Further on, in our encoding and normalization, we keep the non-normalized columns as they already are, which include income, name, email, similarity, distance, request, source, etc. That we will be processing further on using feature engineering inside this application. So basically, since BigQuery sandbox is free, but the thing is, it sometimes requires billing info to set up, which is why you guys don't have this file. However, we're going to be sending all of this code after the study jam to all of you, so there's no need to worry about that. Further on, if you go on to feature engineering, it's feature engineering is basically about creating new features or working on the pre-existing features to improve them for the model's assessment. If we look here, we're creating a new feature income per age, where we are combining both features income and customer age. What we're doing is we're using a case statement. Just like in Python, we use else statements. We can use case statements here. We're seeing if customer age is 0, then we're using one exponent minus 3. Else, if it's not 0, we're dividing it by income and we're creating a new feature income per age. Secondly, the new feature session velocity ratio. We're using the session length in minutes and simply dividing it by velocity of 24 hours and creating a new feature called session velocity ratio, which will basically indicate uh, which will basically create the ratio of session length and the velocity of transactions per 24 hours. Hence, hence making the model understand both trends. Thirdly, if you look at this new feature address permanently, the feature current address month count is divided by previous address month count. However, when we see the case statement, we can see there are 0 values of previous address months count column. So if they are 0, we are using a very minimal value such as 1 exponent minus 5, which is pretty close to 0 but not 0. so that we can carry out the division successfully. If it's not zero, we're just simply using the value stored in previous address minus count for that row. And then we're creating a new feature named added dependency from all of this division and arithmetical operations. Thirdly, there is new feature email and phone validity interaction. What we're doing is we're basically multiplying features. Since email is free, it is also a numerical categorical feature, and phone valid is also a numerical categorical feature. So we're multiplying these both to create email phone valid. Lastly, there is a new feature called credit risk score per bank once count. Since credit risk score is basically a feature which indicates if somebody like how much loan is somebody going to get, or yeah. And what we do is credit risk score is divided by bank months count. So it basically divides the credit risk score provided by your bank uh, by the maximum time you've opened your bank account. Like the bank months count is basically the maximum months you open your bank account. So if it's zero, once again we're using a value of 1 exponent minus 5, which is very close to zero. And if it's not zero, we're using the original value and creating a new relation feature, and we're going to be storing this in train resampled FPGA, which you can see. If you see a preview of the data, we're going to find all the new features here. This is the new feature section, length and width features created. We can see the values are a bit changed, as well as have a lot of decimals as well. Since multiplication with another values causes extension decimals. Uh, Further on, these are all encoded features and normalized features included. These are all encoded from categorical, so that one indicates yes and zero indicates no in general conditions. Thirdly, if we go on to the train test split. So since model is since any machine learning model requires training data as well as testing data. So you need to give it training data to train so that it understands the trends. And then finally, to assess its score, you need to give it the testing data and use assessing techniques like mean, absolute score, etc. that we're going to be showing you further in this workshop. Thirdly, if we talk about training, testing split, there are three types of data fields that are performed. There is training data, there is validation data, and then there is testing data. So for then you can set a certain percentage of data you need to set. For example, for this, we're creating a training table which contains 70% of marginal data. And we're splitting the data randomly so that there's no bias in our final training data. And secondly, we're just checking here what the percentage is about as well as the random values correct. And we're combining all the data into one data set using the union or statement. Secondly, we're creating the validation data set, which is also 10% of the original data. Uh, we're again using random values so that there's no bias when creating the data set. When getting the final data set and checking it here to ensure that randomness is guaranteed. Lastly, we're creating a testing data set, which is also 10% of the original data. We're again using random randomization to ensure there is no bias in the final data set. That's all for the big query part. And now we're going to move on to the board.
Hi. So just a question, how many of you guys use STL before? So later we will send you guys the BigQuery file that I might talk about just now after the event ends into your Gmail, because just to mention again, BigQuery is a bit lengthy to set up, and you need a bank card and everything to set up, so it's a bit lengthy. So we skip the part and just did some explanation on that. So to sum up what Ahmed said during the presentation just now, basically in the industry use wise, BigQuery is used to extract raw data from like the industry databases and then do some manipulation. Maybe they need to derive like new columns into their databases and join tables to do whatever they need to do after that, like training machine learning model or like do it for like application of like development after that. And they basically use the BigQuery to like inspect the data in their database. And after the BigQuery, they will have like a ready data set, and then they can just export it into their Visual Studio Code or like Google Colab, and then they can do whatever they need to do there. So the next section part will be doing the fraud detection machine learning training model part. So we will send you guys the file on that. Yeah, the file is in this QR code. You can scan it with your phone and then just download the zip file and then open it into your Google Drive, My Drive. You guys can just raise your hand if you guys have any issue that we can come over.
For me, oh, I got it. I found it. Daughters? No, just Android directories are so see the file size limit.
When it's not to load the file.
I was looking.
Yeah, after downloading the file to the local file, you can just upload it to your Google Drive, My Drive. Then all the data set can just be loaded into the Google Colab.
No, we got it that file download. I am not uploading What's small? Just on your phone. You have to export. I guess do all that.
Right?
Yeah.
The data set is very big. So okay. Okay. Maybe we wait for like 2 minutes more for everyone to open.
Still take this one.
Okay, sure. Can everyone open the IPYMB file, like the Google Color file from the drive? Yeah, that's good. Show them the IPYMB file, the Google Color file. Is everyone here from computer science or like data science? Can you raise your hand if you are from computer science? What about data science? Okay, so basically, how many of you guys have taken a deep learning unit, 3181? It's okay, this one is not as deep as deep learning, it's just data science and machine learning project. So this will be our next part. Basically, the data we get from the BigQuery, what Amir mentioned, we clean it and then we export it into Drive. So whichever data you loaded here is already clean, so it can just be processed from here.
You wanna go down?
There's no like code along section in this workshop, so we just share you guys the file to like keep track of what we are talking. Yeah, so everyone has the file already, right? Okay, great. So first step, we basically print the structure of the data frame, such as like the section length in minutes, credit risk score, and like the data basically like we need for training model. And then we need to check if there's missing values because it will affect our model later on. So there's no missing value. So there's no any like removing missing value or needed, but we just put it there just in case. Yeah. So basically we want to visualize the data that we already have to get more insights on what the data provide. So this is a box plot basically showing income and like the fraud status. So in these green boxes, you can see that for non-fraud data, the income is evenly spreaded, but then for the fraud cases in the red color box plot, there's a higher income. So we can make an assumption that those scammers usually target like user with higher income to do the scamming. So for next section, we have money fraud cases. So throughout the year, we want to see like which month has like the more fraud cases. So we need to be more alert. So this is like a chart. So in front is maybe like January to like March, and then you can see like towards the end of the year, like October to December, there's more fraud cases that's happening. And from this data set, you can see that the fraud proportion to non-fraud data is very small. Only 1% of the fraud data is fraudulent, and then the 98% of it is non-fraud. So basically, we need to do some post-processing to balance out the class imbalance. This one is just an overview of the data of all the variables and how it's normalized. And for this one, we can see that we assume the user who uses free email has more tendency of getting scammed compared to like non-free email. And users who log in their bank account in multiple devices has a tendency to get scammed more than account that's logged in just one device. So this data is exported back to the drive to do the normalization in BigQuery, and then after that we read the data set and feature engineering as well, and then we split the data set into train value and test. So basically, we need 70% of the data to train the model, and then validation data is basically like a pre-test data set where we want to validate the model on the performance and then like fine-tune it before it's like the final version of the model. Then we use the test data set to test the model on its accuracy. So in this case, you can see the number of fraud cases in the whole data set is only like 3,000 rows, but then number of non-fraud cases is like 300,000. So basically, we need to balance out the class. It's like the concept where if you go into a plane, there's like 100 passengers into a plane, and then 99 of them are like normal, but one of them might carry a bomb. So if you train the model as like all of them are normal passenger, you're ignoring the one that's carrying the bomb, even though the accuracy is 99%. So you need to increase the sample size of like the smaller sample size, the minority sample size as well, into like a 50-50 balance. So your model is less likely to be biased towards one. Yeah, so we do random undersample and small oversampling. So basically, first step, we reduce the majority of the class first because the data set is a little too big. And after that, we do oversampling to increase the minority of the class. The second step, we remove correlation, high correlation features. So basically, some feature might have very high correlation that tends to overfit the model. So basically, if two variables is too similar, it might cause overfitting in the model, and that is not what we want. So from this correlation heat map, we kind of identify which variable is like more common, like more similar. So we set the similarity score to 0.8. So whichever variable is higher than 0.8, we just remove it from our data set here. And this is the final data set we get. where we want to train model. Anyone have any question or like anything that you're unsure of? Can just raise your hand. So let's move on to the next part, which is finally training the data with the model. So we have three models used here, which is logistic regression, random forest, and XGBoost. These are the more famous model for classification model. Classification model is basically classify if it's yes or no, like 0 or 1, yes or no. Just a little brief about the model. It's pre-trained model, so we just import it. There's no thing we need to do like manually. Yeah. So logistic regression model is basically classify the data into yes or no with this probability. Let's say like the probability of it being yes is like 0.8, so you classify it as yes. And for random forest and attributes is a combination of decision tree. So decision tree is basically one of the machine learning model. It will ask question and split it into different nodes. Basically, from the first step, maybe they ask like, is this email free? Yes or no? And then to the last node, they will ask like, is this a fraud cases? Yes or no? And then random decision tree basically runs many decision tree in parallel, and then get like a average of the score to determine if it's fraud or not. And for XGBoost, it runs in sequentially. So basically, you build like a very simple decision tree model first, and then the second decision tree model they build will be from the first decision tree learning from its mistakes. So maybe the accuracy of the first decision tree is like 60%, and they see what they did that wrongly there, then they improve it from the second decision tree, and then like move on from there. Just keep minimizing the mistake from the previous decision tree. So this is called like the boosting method, and random forest will be a bagging method. From here we can see that the model for the logistic regression is around 0.89, and random forest is around 0.92916, and the XGBoost is around 0.91. So we can conclude that the random forest is like a better model for this data set. So after this step, it will be hyperparameter tuning, which is the purpose of the validation set. So basically, the validation step will fine tune is to help to fine tune the model of the train model that we have from previous step, which is the random forest. We use grid search here. So basically, there's a few parameters so you can like change out a bit and test out which one is the better accuracy. So we list out like the number of estimator as well as like the maximum depth. Then you will look through like you go through every step of yeah, so basically you will like go through every combination of this and see like which one is like the better fit for this data set. Then you will just output, oh, it's just a max depth of 10 and number estimator of like 300. Then we can finalize our model from here. So this is where our test data set comes in. Basically, we will finally test our model and see the performance of our model. We achieve an accuracy of like around 0.9 from our model that we already tuned. And then The metrics we use to evaluate this model is the accuracy as well as the mean absolute error. Absolute error is basically like accuracy is basically like total correctly detected, correctly predicted over like the total amount of like all the data set, as well as precision recall is um quite important as well. Basically, precision is like out of the cases the model predicted as fraud, how many were like actually fraud? Let's say like 100 of it is detected as fraud, 80 of them are real. So basically, the precision is like 80%. And then out of all actual fraud cases, how many did the model actually catch? It's aim is recalled. And out of 500 model fraud cases, the model caught 400. So basically, the recall is like 80%. We'll just have a little overview and come out like the steps just now. So basically what we did is data manipulation. EDA is basically exploratory data analysis through like the charts just now, like the box plot and like the pie charts. And then feature engineering is creating like new columns from the BigQuery to improve, to give more information to our model. And then we also did data cleaning, like handling missing values, and data transformation, like changing categorical data to numerical data. The second step we did in BigQuery is data normalization as well. Basically, we scaling the data to like a more consistent manner. And then what we did in the Google Colab using Python was model training. So basically, this was the model that we used, which supervised learning, because we have like a target variable as well as the variable that we want to train. And lastly is the model testing techniques, such as the accuracy, precision, and recall, to test how well our model performs. Does anyone have any question?
Okay, guys, so I'll also show you how BigQuery sandbox sign-in works, just in case you want to do it on your own. Just give me a second. What you do is this is the website. This is basically a Google Cloud technology. What you do is you search your BigQuery sandbox simply. It should show up as the first link. If not, you can just directly type out this link and search up Google Cloud as well. Do you guys have any questions until now? Any issues, any questions, anything? Okay. So what you do is you press go to BigQuery here, or you can either directly copy paste the link. That's all on you. Further on, it directly brings you to BigQuery Sandbox. You can just close this navigation menu here. And how you're gonna start is you're gonna press add. You can either upload a local file from your laptop. Once again, as I told you, you can either upload a CSV file or an Excel file, or you can directly link a Google Cloud Storage service or other external services as well. As you can see, there are multiple services like MySQL, PostgreSQL, AWS, Azure, etc. Apache as well, which is a pretty well-known service. Further on, like as soon as you, even if you go to the local file, you have the drive option. Amazon Azure, you can also use an existing table which has already been incorporated into BigQuery to duplicate it or use it further on. You can just upload the file. Thirdly, you need to define the project name here, and then you need to create a new data set. Since basically, what you need to do is in BigQuery, before uploading a table, you need to define a new data set where you can upload the table as well as where all your queries and stuff are stored. You can define the table size and stuff here, the table type. The most important thing here is schema, which is basically how the table is formatted. So there are columns and there are rows in the table. In the schema, all of this stuff is defined. It's kind of like metadata, but this is for data sets. And then you can just press create table. Do you guys have any questions, any clarifications? I need to upload a data set. So, yes. To make it, it has a limit of 100 MB. So this can be oh, yeah. Okay, guys. So I can also show you how to create a table for you. What I did is, as we have all provided the folder to you as well through the QR. Hopefully, you must have all downloaded it. I've selected this file, which is the final feature engineer dataset. This is the validation set. What I did is I basically downloaded it here into my local storage, and then I go into the BigQuery create table option. I press the browse option, and then I select the dataset I just downloaded and press open. So we're loading it into the fraud detection dataset as I've already created it. This is the table and this is the dataset which comprises of all the queries and stuff. The destination table is required, which is basically the destination name where the table will be stored. So we can just write fraud engineer. And then since this is a native table, you can press the schema to auto detect so that it automatically generates the schema, which is it will detect where the columns are, what the column names are, and how it will be uploaded. You can then just press. There are advanced options as well, which is basically, for example, just like the drop NA statement in Python pandas, right? Where it drops the empty cells or empty columns. You can define a statement here. For example, if there is an empty cell, you can uh, you can write to it. You can change the value of the empty cell. You can also see the number of errors. You can also change the number of errors allowed. There's a field delimiter, which is basically, for example, as a comma, if you write somebody's name, the delimiter there is a comma, whereas you can change it here. You can use tab, you can use pipe, which is basically this icon, this symbol, and you can also use a custom one, for example, a question mark or a full stop. Secondly, if we now just press create table, it's going to create a new table and upload it into the dataset.
You don't see it. You just go.
Okay, so you can also check out the jobs here. I can just press close here and then Yes. So it created the table. I can press go to table once. I can press go to table here, and this is the table we just uploaded. It's obviously in the fraud detection dataset, as I already told you. This is the table name we defined when uploading it, which is fraud engineer. We can preview it here, which is basically viewing all the columns and the data. Uh, this is the final data set for the validation set. As you all can see, these are encoded features. There are feature engineered columns as well that we just created. And then if you want to view some major details on the data set, so basically, what is this? One interesting thing when you and I were learning BigQuery Sandbox, one interesting thing is Google has established cloud servers at different locations. So when you use BigQuery, it tells you where like in which cloud location your data set is being stored. For example, this one is being stored in the US. There are other details as well, such as if this data set is sensitive or not. Collected details like number of rows and data set size, which is the same as when we downloaded it. Um, then there is preview, and then there is schema as well, which obviously shows what the type of the columns are. For example, the first one in 64 field 0, which is I think term column. It's integer data type. The section ends in when it's flow data type. Etc. There's the table explorer as well. You can run custom queries on here to get distinct values and stuff. You can also run general queries on the dataset by pressing the query icon here, and it creates a new query. As I already told you in the introduction, the level 1000 is basically it will limit the output to 1000 rows to save on resources, but you can easily remove this. And for example, if I if I put an asterisk here, it's going to output all the data from the data set we just uploaded. As you can see, it output all the data as we just uploaded into the data set 96,656 rows here, as well as 96,656 rows. You can also find some insights of the data. Apparently, these features of BigQuery are great, and since we're using the sandbox, which is the free version of BigQuery and a temporary version, these features are not available to us. Also, guys, just to mention, the BigQuery sandbox is only supported for 60 days from the date you start using it. After that, all of your queries and dataset and all the data tables uploaded into your account's BigQuery sandbox will be deleted and refreshed. So do keep this in mind when exploring BigQuery sandbox and conducting your own personal projects on sandbox. Do you do you guys have any questions? Anything you want to help with? If you guys have any questions in terms of BigQuery or Colab or even machine learning in general or SQL syntax, anything you guys want to ask. Okay, so and then just okay, guys. So we're gonna be ending the online session for now. Sorry guys, so we're gonna be ending the online session for now. If you guys have any questions, I can just answer in the chat. This is target already asked. If not, I'm gonna end the online session. Thank you guys. Thank you for joining. And thank you for sticking to all the session. Bye bye.